So, welcome to the video lecture series on HCF and LCM session 2. In today's video lecture, we will be learning about the remaining topics pertaining to HCF and LCM. So, in the last class, we learned about the way of doing HCF and LCM using long division method, and HCF also have another method called as repeated division method. So, let us assume that I want to find the LCM of 12 and 18. Okay. So, I want to find the HCF. I want to find the HCF of 12 and 18. So HCF of 12 and 18. Now, in this case, which is the biggest number? 18 is called as the biggest number. So, we go for 18. Okay. Divide this by 12, smallest number. Now, this goes one time and the remainder is actually 6. Now, what we have to do is, we have to take this remainder as a divisor and the divisor as a dividend. So, now I take 12 here. Now, 12 goes 2 times in 6. So, now you get an answer called as 0. Since 6 is actually dividing 12. So, 6 is called as HCF now. So, HCF of 12 and 18 is called as 6. I will take another number. Let us assume that we take 24, 36 and 48. Okay. Now, when I want to find the HCF of all these three, now we take the biggest number here, biggest number is 48 and the second biggest number is 36. Okay. So, now we take 48 divided by 36. Now, 36 goes one time in 48, now we get 12. Now, take this remainder 12 and divide the divisor. So, divisor is now 36. So, 36 goes how many times? 3 times in 12. Now, as far as the last two numbers is concerned, it is called as 12. Now, we could not come to a conclusion that 12 is HCF because we are left with one more number called as 24. Now, take this 24, divide by the HCF now. The HCF we have got is actually 12. We have to ensure that whether it's again you get the same answer. Now, 24 is divisible by 12. So, obviously 12 is called as a HCF of this. Now, this is the way of doing this. Now, we will take another number. Let us assume that we have 12, 16 and 32. Now, we can see that we want to find the HCF of 12, 16 and 32. So, biggest two numbers 32 and 16. So, we will take this 32 and divide by 16. 32 goes one time, 2 times here. So, now as far as this is concerned, 16 is called as HCF. Now, take this 16. Now, we will try to divide 12. So, now what we have to do is, now the smallest number is actually 12 and the biggest number is actually 16 in this case. So, 16 should be divided by 12. Now, it goes one time. So, we are left with the 4 remainder. Now, again we divide this divisor 12 by 4. So, 12 goes 3 times and we are left with 0. So, now the HCF for 12, 16 and 32 is actually called as 4. Okay. So, this is the way of continuing with HCF. This is called as a long division method. Now, let us assume that take some other values which pertaining to some other values which is related to this. Now, want to find the HCF of. So, HCF of 28, 54 and 62. Now, see here, let us assume that because two numbers is 62 and 54. So, we will divide this 62 by 54. Now, we will be left out with one time and we will be left out with 8 now. Now, use this divisor 8 and divide this 54. 54, how many times it goes? 6 8s are 48. So, it goes 6 times and we are left out with 6. Now, take this 6, divide this 8. So, it goes one time, will be left out with 2. Now, take this 2 as a reminder divisor and 6 as a dividend. So, it goes how many times? So, 6 is divisible by 2 3 times. Now, 2 is called as HCF. So, the HCF for 54 and 62 is actually 2. Now, what we have to do? We have to find the HCF between 28 and 2. Now, apply biggest number is 28. So, 28. Now, the HCF we have obtained is 2. Divide this by 2. Now, 28 goes 15 times into. Now, obviously, the HCF of 28, 54 and 62 is called as 2. So, this is a way of actually doing the HCF. We called as repeated division method. So, we will also do another methodology. We will try another method here. Another problem. So, let us assume that I want to find the HCF of 9. So, I will use some other color here. Okay. So, I want to find the HCF of 9, 15 and 21. Now, when you just closely observe this, 15 and 21. So, 21 divided by 15, it goes one time. So, remainder is 6. Now, 6 divided by 15, 15 goes 2 times. Now, 3 is left out. Now, 3 and 6. So, now the HCF is actually 3. Now, the HCF for these two numbers is actually 3. Now, we take 9 and 3. So, we have to find the HCF of 9 and 3, which is the biggest number. 9 is the biggest number and 3 is called as the smallest number. So, divide this biggest number 9 by 3. Now, how many times it goes? It goes 3 times. So, you are left with 0. Now, the HCF is actually called as 3 for this one. So, HCF is called as 3. Now, you can have a deep understanding that how it works. I hope so you are able to understand this. So, let us assume that we want to find the HCF of 44, 80 and 96. Okay. Now, we want to find the HCF of this. So, first we will take two biggest numbers, 96, 80. Now, it goes one time. So, 16. Now, 80 divided by 16, 5 times it goes. So, as far as these two numbers is concerned, 16 is called as a HCF. Now, when we go for 44, want to find out 44 and 16. So, biggest number is 44, the smallest number is 16. So, we divide 44 by 16. So, it goes 2 times. So, we are left out with 12. Now, 12 divided by 16. So, it goes one time, left with 4. Now, 4 dividing 12. Now, it will be exactly dividing 12. So, the HCF for this 3 numbers is called as 4. 4 is called as a HCF of this. So, that is about the way of finding the HCF. It is called as a repeated division method. So, we will go for the next one. So, the relationship between HCF and LCM. So, the relationship between HCF and LCM is product of two numbers. So, product of two numbers N1 and N2. So, product of two numbers N1 into N2 is equal to HCF into LCM. So, this is the factor for this. Now, let us assume that we have given an LCM for this. Let us assume we have a number 1 is equal to 8, HCF is equal to 4 and LCM is 24. LCM is 24. Now, what is the second number? So, what is the second number? So, number 2 is equal to what? If this is the question, okay. Now, if this is the question, number 1 has been given, HCF has been given, LCM has been given, how to find it? Now, you just take this relationship N1 into N2, N1 into N2. Now, when we apply this N1 into N2, so we will want to find number 2. So, number 2 is here. Now, we have HCF, we have had it, LCM, we have it and divided by number 1. So, what is HCF here? HCF is 4 and LCM is 24 and number 1 is actually 8, so this goes 2 times now, so this goes 12 times. So number 2 is actually 12. Now just cross verify whether the answer is right. Now number 1 is 8 and number 2 is 12 is equal to HCF is 4 and LCM is 24. Okay, so 8 12s are 96 and 4 24s are 96. So both are equal. Now that is the relationship between HCF and LCM. Okay. Now we can go for the next one. So find the LCM of 14, 18 and 22. So here LCM has been given. So LCM, you know that we go for a long division method. So 14, 18 and 22. So now all will be divisible by 2. So this goes 7 times, this goes 9 times and this goes 11 times. Now all are these numbers are called as prime numbers. So we will try to divide by 3. So 7 is not divisible by 3, but 9 is divisible by 3. So 7 and this goes 3 times 11. Okay, now we will just make this 3 as 7 and this goes 1 time, this goes 11 times. Now divide by 7. Now this goes 1 time, this goes 1 time and 11, and finally divide by 11. So 1, 1 and 1. Now just multiply all these factors. So 2 into 3 into 3 into 7 into 11. Now 2 into 3 is 6, 6 into 3 is 18, 18 into 7 is 116, sorry 126, 18 into 7 is 126 and 126 into 11, so 1260 by 126 will be 6, 8, 3 and 1. So the answer is equal to 1386 is an answer. So 1386 is called as an LCM of this. So there are alternative ways for doing this. We can also go for the factorization method, and otherwise we can go for a shortcut method also. Now it's better if you have anything like this, you go by this one. Now the HCF of 14, 30 and 42. So we will go for repeated division method for finding this. So biggest number, two numbers are 42 and 30. So biggest number is 42 divided by 30. Now this goes 1 time, remainder is 12, and divide this 30 by 12, it goes 2 times 24, remainder is 6. So 6 dividing 12, it exactly divides it. So HCF is actually 6. Now for the first two numbers, HCF is 6. Now you have to find for 14 also. 14 and 6, which is the biggest number? 14 is the biggest number. So divide the small number by big number by small number. 14 divided by 6. So this goes 12 up to 12. Now remainder is 2. Now you take this 6, divide by 2. So it goes, it exactly divides. So the HCF of 14, 30 and 42 is actually 2, is called as an HCF. Okay. Now the very crucial part here is when you want to find the HCM on LCM for fractions. So when the question is asked for HCF, so HCF of numerator and denominator. Okay, numerator and denominator means first if it has been asked for numerator 1 and denominator 1 and numerator 2, denominator 2. So if the question is asked like this, now if the question has been asked for HCF, that means you have to do like this. So the answer will be HCF of numerator 1 and numerator 2. Okay, divided by the LCM of denominator 1 and denominator 2. So that is the answer. Okay, if the question is asked as HCF, find the HCF of numerators divided by the LCM of denominators. Suppose if the question is asked like this, say for example, if the question is asked like this, LCM if it is asked for LCM of numerator 1 and numerator 2. Okay, not only for numerator 2 or numerator 1, you can up to apply for n number of times. Okay, now denominator 1 comma denominator 2. Okay, the question has been given like this. So what you have to do is, now the final answer is LCM of numerator 1 comma numerator 2 divided by HCF of denominator 1 and denominator 2. So that's that. Okay, if the question is asked to find HCF of numerator 1 and numerator 2 divided by LCM of denominator 1 and denominator 2. If the question is asked for LCM of numerator 1 and numerator 2 divided by the HCF of denominator 1 and denominator 2. Now, both questions has been asked here. So, HCF and LCM of 4, 5 and 10, 7. Now, we will find the HCF now. So, HCF means we have to find the HCF of 4 and 10. So, 4 and 10, what will be the HCF? So, 4 and 10, what will be the HCF? So, biggest number is 10 divided by 4. So, goes 8 times, 2 times divided by 2. Now, 4, 4, 0. So, 0. Now, the HCF is actually 2. So, in this case, for 4 and 10, HCF is actually 2. So, HCF of 4 comma 10 is equal to 2. Now, what we have to do? We have to find the LCM of 5 and 7. So, LCM of 5 and 7. So, LCM of 5 and 7 both are co-prime to each other. We can directly multiply. 5 into 7 is 35. So, the answer for HCF of 4 and 5 and 10 and 7 is equal to 2 divided by 35. 2 divided by 35. This is the HCF answer. Now, the second question is actually asked for LCM. LCM of 4 and 10. So, LCM of 4 and 10, you know that find the LCM of numerator. What is the numerator here? 4 and 10 are numerator. 4 and 10, what is the numerator here? When you find 4 and 10, now 10 is the biggest number. 10 is not divisible by 4. Now, you make 10 2 times. 2 times of 10 will be 20. 20 divided by 4, yes, exactly, it will be divisible. So, LCM of 4 and 10 is actually 20. Now, the next one is HCF of denominator. HCF, what is the denominator here? 5 and 7 is called as a denominator. So, you cannot find any common term between 5 and 7 except 1. So, HCF of 5 and 7 is actually 1. So, the answer of LCM of 4, 1, 5 and 10 and 7 is equal to LCM of numerators is actually 20 and HCF of denominators 5 and 7 is 1. So, the answer is equal to 20 is an answer. So, this is a way of actually identifying this for fractions. Now, the HCF and LCM of two numbers is 4 and 24. If one number is 6, what is the other number? So, now we have to apply the relationship. Now, the relationship is actually N1 into N2 is equal to HCF into LCM. So, this is the relationship between HCF and LCM. Now, you know that what is N1? N1 is 6. Okay. Now, N2 we have to find it out. Now, HCF is actually 4, LCM is actually 24. Now, N2 is equal to 4 into 24 divided by 6. Now, this goes 4 times here. Okay. So, 4 4s are 16. Now, you know that N1 value, N2 value is 16. So, now you can cross verify this. N1 is 6, N2 is 16 is equal to 4 into 24. So, you know 6 into 16 is actually 96. 4 into 24 is 96, 96 equal to 96. So, the answer is correct. So, N2 value is actually 16 is an answer. So, hope so you are able to understand or follow this. Now, the HCF and LCM is 4 and 80. How many pairs of numbers can be formed? So, we have to apply the same relationship here. Now, let us assume that there are two numbers here. No, we are not going to find the numbers here. We have to find how many pairs are there. So, you know that n1, let us assume that n1 is equal to x and n2 is equal to y. Okay, and HCF and LCM has been given here. Now understand that when anything is actually HCF is given, that means it is actually the number of times of HCF. So HCF here is actually 4. So we will make this x as 4x. So n1 is equal to 4x and n2 is equal to 4y. Now we apply the scheme here. So n1 into n2 is equal to HCF into LCM. Now closely observe this. What is n1 here? n1 is actually 4x into what is n2? n2 is actually 4y is equal to HCF is 4 and LCM is actually 80. Now just 4xy will be, I just transfer xy here, x into y or xy is equivalent to 4 by 80 divided by 4 by 4. Okay, I just bring this two force here. Now this force strikes off here and this 4 when you strike off it, it will be 20. Okay, now you know that x into y is equal to 20. Now when you will get this 20, okay, now understand that this x and y should be co-prime. This x and y should be co-prime to each other to get this 20. Okay, now what is the one possibility? If x is 1 and y is 20, now I will get an answer called as 1 into 20 is 20. Okay, x is 1 and y is 20, you will get 1 into 20 is 20, or otherwise if y is 1 and x is 20, also you will get the same answer. Okay, so interchanging the pairs doesn't matter here. Now understand that if x is 1, y is 20, now what is the co-prime between these two numbers? Co-prime is 1, so obviously this is accepted. Now what is the other way of doing that? Okay, now if x is 5 and y is 4, we will get 20. Now if x is 5 and y is 4, we will get 20 also in this case. Okay, now 5 and 4 are actually co-prime to each other. Okay, now I cannot apply x is equal to 10 and y is equal to 2. Why? Because these two numbers are not co-prime. Okay, I cannot make this as a pair. Why? Because 10 and 2 does not have a common HCF called as 1. Okay, it is not co-prime because 10 and 2 will be divisible by 2 itself. So we cannot take this as a pair. So there are only two pairs here. One is 1, 20 and 5, 4. The number of pairs is actually 2 pairs. Okay, I cannot take this as a pair because these two numbers are not co-prime. Okay. So 1, 20 or 20, 1 both are identical pairs and 5, 4 and 4, 5 are identical pairs. So we will get only 2 pairs here. So I hope so you are able to understand this. Now we will go for the next one. So HCF and LCM is 3 and 45. So how many pairs are here? Now we will make N1 is equal to, now what is the HCF here? N1 HCF is actually 3. So I will make it as 3x. N2 is equal to again 3y. Now we just make this relationship N1 into N2 is equal to HCF into LCM. Okay, so N1 we know that what is the value? N1 is actually 3x into N2 is actually 3y and HCF is actually 3 and LCM is actually 45. Okay, now we will make this x into y, that is xy is equal to 3 into 45 divided by 3 into 3. Okay, now this 3 strikes off, this 3 goes 15 times. Now x into y is equal to 15. Now what are the pairs here? Now I can make x as 1 and y as 3. X as 1 and y as 15. So 1, 15 is a pair because these two are actually co-prime to each other. Now I can make x as 3 and y as 5. You will get 3 into 5 is 15. Okay. Now these are the only two pairs which can be obtained here. okay, because these are actually co-prime. 3 and 5 have a common co-prime called as 1. So they should be co-prime to each other. These two numbers should be co-prime to each other. What is co-prime? So co-prime means HCF of two numbers. Okay, say for example, HCF of number 1 and number 2 should be equivalent to 1. Then it is called as co-prime. Okay, that means the common divisor should be 1. So there are only two pairs here, 1 and 15, 3 and 5. So the two pairs, so there are two pairs. Okay, so you are able to understand this. Okay, now we will go for the application perspective of LCM and HCF here. So in this case, a question has been given. A school has 153 girls and 204 boys. Okay, a school has 153 girls and 204 boys. The entire strength has to be accommodated in a class of equal strength. And how many girls and how many boys classes can be formed? Now see here, we have to apply. It has been said as equal strength. If the question, this is called as a key. When it has been said as equal strength, we have to apply the concept called as HCF here. So HCF or greatest common divisor. Now class strength should be equal. That means there should be boys class and girls class. I am not mixing boys class and girls class together. Okay, there should be boys class separate, girls class separate, and the length of the strength of the class should be equivalent. Strength of the class should be equivalent. Okay. Now in this case, we have to find the HCF of these two numbers. Okay. The first biggest number is 204 and the smallest number is 153. Okay. Now 153 goes how many times? Only one time here. So I will be left out with a number called as 51. Okay. Now take this 51, divide this 153. So 153 goes 3 times in 51 and you will be left out with 0. So obviously the HCF is called as 51. So if the HCF is 51, that is nothing but it is called as a class strength. So the class strength, the strength of one class is actually 51. Now what is the question says? How many girls and boys class can be formed? Okay, what is the strength of the girls now? So number of girls class. So number of girls class, you know that the strength of the girls is 153 divided by the strength of class strength is 51. So you will get 3 girls classes. Okay. Now you will get 3 girls classes. Now we will go for computing the boys class now. Computing the boys class. So the boys class, number of boys class is equal to 204 now divided by 51. So number of boys class is actually 4. Okay. So the total number of classes are girls class is 3 and boys class is 4. So total number of 7 classes will be there. So this is the way of actually solving the problem using HCF for practical scenarios. So we'll go for the next one. So a gift box should be distributed to the participants of a function which contains sweets, biscuits and apples. There are 88 sweets, 104 biscuits and 120 apples. How many gift boxes can be made which contains all these items equally? Okay. So that means equally in the sense a gift box should have all these 3 items and all the gift boxes should have equal items. That is the meaning of it. Okay. So say for example, if one gift box contains 2 sweets and 3 biscuits, another gift box should also contain the same 2 sweets and 3 biscuits. If you form like that, how many gift boxes can be formed? Now again, when I say it is the key is actually how many gift boxes of equally. If it is equally means again you have to go for the concept called as HCF. Now we have 3 numbers here. So 3 numbers are 88, 104 and 120. So what is the biggest number here? 120 is called as the biggest number. What is the next biggest number? 104. Now 104 goes one time in 120, so remainder is 16. Now 16, 104. So 34, 80, 96. Okay, so it goes 96 and remainder is 8. Now again 8, 16. So now the number of gift boxes, the HCF is actually 8 here. So for HCF is equal to 8 for the numbers called as 104 and 120. Now what is another number here? We are left out with 8 here, 88. So we have to find HCF of 88 and this 8 here. Now what you have to, the biggest number is 88. So 88 divided by 8, how many times it goes? It goes 11 times. So remainder is 0. So again HCF of 88 and 8 is actually 8. Now the HCF of all these three numbers is called as 8. That means that this is called as a number of gift boxes. So number of gift boxes is equal to 8. Okay. Now what is the question? A gift box contains how many sweets, biscuits and apples? Now see here, one gift box contains sweet. One gift box contains sweets. How many sweets? So there are 88 sweets and I have 8 gift boxes. Okay, so one gift box can contain 11 sweets. Okay, now one gift box contains biscuits. How many biscuits it can contain? So there are 104 biscuits and 8 gift boxes. Now I can have 13 biscuits in one gift box. Okay, now one gift box contain how many apples? So 120. So apples, it is apples. Okay, so how many apples there are there? 120 apples are there and 8 gift boxes are there. Now if apples are equally getting distributed, now I will get 15 apples. Okay, now a gift box can contain, okay, now we will go for the actual problem. A gift box contain how many sweets, how many biscuits and apples? Okay, there are 8 gift boxes. Now we will go for the problem now. So here gift box contain there are 11 sweets and 13 biscuits and 15 apples. Okay, so altogether a gift box contain 39 items. Okay, it has 39 items. Okay, one gift box contains 39 items. Okay, now how many gift boxes there are? There are 8 gift boxes. Now so that all these items will be equally get distributed. So that is the meaning of this. Now now we will go for HCF also, LCM also. So I will just go for LCM. Let us understand that. So now this is for HCF now. So okay, I'll go for LCM. Okay. Okay. Now one practical application for LCM. So a birthday party. So there is a birthday party. Is decorated with serial lights. Okay. So it is decorated with 3 serial lights. Let us see that red light glows every 2 seconds. Okay, and there is a green light, glows every 5 seconds, and there is an orange light, so that glows every 6 seconds. Okay. Now this keeps on blinking on the respective time ratios. Now all these three lights, that is red light, green light and orange lights, together glows at the time called as 8 p.m. Okay. So together they will glow at 8 p.m. Now what time they will glow again, glow together again. Okay, what time they will glow together again? So that is the problem. Now you know that we want to find a uniform timing in when all this together glow. Now what is the methodology? Methodology is actually you have to find the LCM of this. So LCM of 2, 5 and 6 seconds. Okay. Now 2 is actually a divisor of factor of 6, so we ignore that. Now we take 5 and 6. 5 and 6 are co-prime to each other, so 5 into 6 is actually called as 30. So 30 is called as an LCM. 30 is called as an LCM of this. Now that means when it glows at 8 a.m, so together they glow at 8 a.m, the next time is actually 8 a.m 30 seconds. Okay, so it glow 30 seconds after this. Okay, so 8 a.m 30 seconds it will glow together. So that is the meaning of this. So we have learned about the practical applications of HCF and LCM. So thanks for watching the video. Have a good day.